Happy morning. Today we are discussing surface chemistry. We see the introduction to the surface chemistry. Surface chemistry is closely related to interference and colloidal science. Surface chemistry is important in many critical chemical processes such as enzymatic reactions at high biological interference found in cell wall and membranes. In electronics, at the surface and interference of microchips used in the computers. And the heterogeneous catalysis found in the catalytic converts used for cleaning of emissions in automobile exhausts. So this is about introduction of surface chemistry. So let's see the definition of surface chemistry. Surface science is the study of chemical phenomena that occur at the interference of two phases. So one is, we see here, solid and liquid interference, solid and gas interference, solid and vacuum interference, liquid and gas interference. So it is defined as the study of chemical reactions at interference. So we study the interference of two phases. So next we see the colloids. Colloids is derived from Greek word. So colla equal to glue. So ids equal to like. So which diffuse very slowly in solution and whose solution cannot pass through the membrane, like animal or vegetable membrane, whatever it means. So colloids means which the diffuse very slowly in solution and whose solution cannot pass through animal or vegetable membranes is known as colloids. So examples: starch, albumin, glue. So coming to the colloidal state, a substance is said to be in the colloidal state when it is dispersed in another medium. So in the form of very small particles having diameter of 2 into 10 power minus 4 to 1 into 10 power minus 7 centimeters. So let's see the types of solution. So on the basis of size of particle dispersed size, the solutions may be classified into three types. So one is a true solution, the second one is suspension solution, and the third one is colloidal solution. So let's see the first one, true solution. So true solution, it is a homogeneous solution containing dispersed particles of molecular size, they having less than 10 angstroms or 1 nanometer. Examples: sodium chloride or glucose solution in water. Next, coming to second one, suspension solution. It is a heterogeneous mixture. They containing suspended insoluble particles of size greater than 1000 angstroms. So that is 100 nanometers. Example: sand stirred in water. Next is the colloidal solution. It is a heterogeneous two-phase system. Colloidal solution is a heterogeneous two-phase system in which a substance is distributed in colloidal state in an insoluble medium. So the particles are dispersed in internal phase is called dispersed phase, while the particles are dispersed in insoluble medium or external phase is called dispersed medium. So the particles were dispersed in internal phase or discontinuous phase are called dispersed phase, whereas the particles are dispersed in insoluble medium or external phase is called dispersed medium. So colloidal solutions may also containing a stabilizing agents, a substance which tends to keep their colloidal particles apart, these by avoiding their collisions and consequent settings. So they having these stabilizing agents. So due to stabilizing agents, the formation of colloidal particles are stable. So here we see the diameters of two solution particles. So particles which are dispersed in the suspension solution, the particles which are dispersed in the colloidal solution. So true solutions may having the particle size 10 angstroms. Suspension solution, the particle dispersed, they having the 1000 angstroms in the particle size. In colloidal solution, the particles having 10,000 angstroms. Here we see the dispersed medium, name of the colloidal solution. For examples, we take the dispersed medium as a water. So colloidal solution is a hydrozole. So dispersed medium alcohol, colloidal solution alkazole. Similarly, benzene, benzosole, air, aerosol. Next, we see the characteristics of colloidal state. So what are the characteristics of colloidal state? So it is a heterogeneous system. In this heterogeneous system, the intermediate between a true solution and suspension solution. So colloidal system may be either by aggregation of many small molecules or particles by dispersing a bulk quantity of matter through the grinding. So that means the dispersion of particles from a bulk molecule or a quantity of bulk matter which undergoes grinding, the particles are dispersed. So next, colloidal particles can readily pass through the ordinary filter paper because the pore size of the filter paper is much larger than that of colloidal particles. Next, the colors of the colloidal solution is not always same. So because the particles are dispersed phase, so automatically the particles are dispersed, so which affect the color of the solution. The size and shape of the particles were changes when the particles are dispersed, so which affect the color of the solution. So for example, we see here the spherical gold particles impart a red color to gold solution. So white particles a blue color. Similarly, sulfur solution may be a colorless or light yellow or deep yellow. So in reflected light, while reddish in transmitted light, while reducing transmitted light. So that is the color should be changes when the particles are dispersed, so which affect the color of the solution and shape and size of the particles of the sediments. So absorption. The colloidal particles, due to the presence of unbalanced force on their surfaces, so they attack a variety of suspended particles to their surface. This property has been utilized in dyeing of cotton fabrics. So that is adsorption. So due to their unique size, the colloidal particles may not settle down under the force of gravity. So even on long keeping. So colloidal particles possess much slower rates of diffusion when comparing to the true solution. So generally colloidal particles are charged either all positively or negatively. So the main property, the colloids which possess optical and colligative properties. So next we discuss types of colloidal solutions. So on the basis of their solvent affinity, the colloid solutions are classified into two types. One is lyophilic solutions. The second one is lyophobic solutions. So here the solutions are those which the dispersion medium possess greater affinity for the dispersed phase. So dispersed medium is greater affinity for the dispersed phase is known as lyophilic solutions. Lyo means liquids, philic means affinity of love. So that's why greater affinity in the lyophilic solutions in the dispersed medium. The process greater affinity for the dispersed phase. Examples starch. So lyophobic solutions are those in which there is no affinity in between dispersed medium and dispersed phase. Lyo means liquids, phobic means hating. So that's why there is no affinity between the lyophobic solutions. So there is no affinity between the dispersed medium and dispersed phase. Examples: gold solutions, silver solutions. So here we see the differences between the lyophilic solutions and lyophobic solutions. So what are the differences? Let's see. The formation of lyophobic solution particles. So the formed easily by the more shaking. So no stabilizers is needed for the preserve them. Coming to the lyophobic solutions, they are difficult to prepare. They are formed only by special methods. So they require stabilizers for their stability. So coming to lyophilic solutions, the particles are solvent, they have a greater affinity in the form of single molecules. So whereas in lyophobic solutions, the particles are solvents hating and consist of aggregates of large number of associated molecules. So next we see the surface tension is generally lower than that of the dispersing medium itself in the lyophilic solutions, whereas lyophobic solutions surface tension is almost the same as that of dispersant medium. Next, coming to the viscosity is higher than that of solvents in lyophilic solutions, whereas lyophobic solutions viscosity is about the same as that of medium. Next, coming to particles cannot be detected under ultra microscope. Lyophilic particles, they cannot be detected under ultra microscope. So whereas lyophobic particles can be detected under microscope. So coming to charge, the charge on the particles depends upon the pH of the medium in the lyophilic solutions, whereas lyophobic solutions, the particles have the characteristic either positive or negative charges. So next one, the particles may migrate in either directions under the influence of the electrical field. So here, the particles move in different direction only. Next, coming to here, a stable solubility in lyophilic solutions, lyophobic poor solubility. So next one, coagulation can be brought about only by the addition of large quantities of electrolyte. So coagulation, they require addition of large quantity of electrolytes. Here, in addition of and even a small quantity of electrolyte can causes coagulation in the lyophobic solutions. So coagulation is reversible. So coagulation is irreversible. They have relatively high osmotic pressure, dispersion of freezing point, evolution of boiling point, and having a higher of vapor phase. So they have high osmotic pressure, small deposition of freezing point, and less evolution of boiling point, and less lowering of vapor pressure. So these are the some differences between the lyophilic and the lyophobic solutions. So let's see the synthesis of colloids. By direct reduction method, we are using non-electrolytic reductants to synthesis the colloids. So here we using AuCl3 and formaldehyde and water. So we get colloids. So here we using by making our synthesis of colloids. So we use 3 to 4 ml of 0.2 N potassium carbonate solution and 1 ml of 1% gold chloride solution, and we maintaining the solution in about 150 to 200 ml of distilled water, followed by the gradual addition of 1 to 3 ml of 0.3% formaldehyde solution. So with continuous stirring, we synthesize the colloids. So here we using potassium carbonate as acid to neutralize the acid formed in the order to get the stable solution. So next we discuss stability of colloids. The stability of colloids may be attributed to one or more of the following factors. So let's see what are they. Electric charge. So the dispersed particles of lyophobic colloids are electrically charged, either they having positive charge or negatively charged. So within a colloidal system. So all suspended colloids particles have the same kind of electric charge, or either positive or negative they have in all particles. So with like a charge repel each other, and their mutual repulsion prevent them from join together and setting out. So the accumulation of similar charges on the suspended particles hold them apart and thus stabilize the system. So that is the electric charge. So next, coating of protective substances. Here we using some of the protective agents. We use it in the colloidal system to stabilize the formation of colloids by using protective agents. So next we are using solvation. So solvation factor, the stability of lyophilic solution is basically due to the solvation. The dispersal phase becomes solvated in the presence of liquid dispersal medium. So the dispersal particles are molecules of the dispersing liquid and thus become surrounded by a protective envelope of dispersal medium. Such a solution are very stable. So because the dispersal medium, the lyophilic means they having a greater affinity to the molecules on the surface. So that's why they form as the envelope of dispersal medium. So they have greater affinity between the dispersal phase and dispersed medium. That's why they cover a protective layer is called envelope. So the dispersal phase cannot be easily separated from the envelope of the medium. So because of their greater affinity, the precipitate is formed only by removing first the solvent envelope by dehydration, are followed by the addition of a huge amount of electrolyte. So by using electrolyte or a dehydration process, so we break down the envelope in the solvation process. So where they give a protect for the formation of colloidal particles in the medium and base. So next we discuss the micelles or associated colloids. So what is meant by associated colloids? So the colloids molecules at low concentration act as a strong electrolytes. At low concentration, the colloidal molecules act as a strong electrolytes. At a high concentration, they form stable particles of colloidal dimensions are called micelles. So the colloids at a low temperature, they act as a strong electrolytes. At a higher temperature, they forms as a colloidal particles. Stable particles of colloidal dimensions are called micelles. So micelles have lyophobic tails which get conjugated. At a high concentrated solution, those molecules form aggregates of colloidal size. So we see here citrate ion, so polar head. So this is a head, so this is a tail. So the colloidal aggregates of a soap or detergent molecules formed in the solvent are referred as a micelles. So sodium stearate, so sodium dodecyl sulfate. So here soap or detergent molecules ionize in water to form anion and sodium ion. So sodium citrate dissociates to form citrate ion and sodium ion. So let's see the mechanism here. The sodium citrate undergoes dissociation in the water to give citrate ion and sodium Na plus. So about the large number of citrate ions combined to form a coagulate to form micelle of colloidal particles. So the citrate ions have a long hydrocarbon chains with polar functional groups at one end. So in micelle formation, tails being insoluble in water is directed towards to the center. So tails to be insoluble, so they are directed to the center. So next, the charge on the micelles due to the polar heads. So is accounts for the stability of the particles. The cleaning action of detergents and soap is mainly due to the solubilization of grease into the micelle or emulsification of grease. So these are the two responsible for in cleaning of action of detergents and soap, mainly for the formation of micelles. So let's see the solubilization. So in concentrated solution, the soap anions form micelle spontaneously. So in the solubilization process, the concentrated solution, the soap anions form micelle spontaneously. The hydrocarbon part of a tank are in the interior of micelle and CO minus ions on the surface. Thus, the grease strain is absorbed into the interior of the micelle, which act like a liquid hydrocarbon. So next, coming to the emulsification. So where the soap solution is added to the fabric, the tail of soap anions are penetrate into the grease stain. The polar heads are produced from the grease surface, so and form a charged layer around the stain. Thus, by mutual repulsions, grease droplets are suspended in water. So that is the emulsification. So next, here we see the preparation of colloidal solutions. So how to prepare colloidal solutions? There are two main methods for the preparation of colloidal solutions. So what are they? We discuss here. So let's see the condensation method. Condensation method. So in this method, a large number of particles of molecular size are allowed to condense to form a bigger particles of colloidal dimensions. So in the condensation method, a large number of particles of molecular size are allowed to condense to form a bigger particles of colloidal dimensions is condensation method. So by the in this method, we are doing some small steps for the formation of the bigger particles of colloidal dimensions. So what are they? We discuss here by changing of solvent. By changing the solvent to form bigger particles of colloidal dimensions. By changing the physical state and controlled condensation and some chemical methods, we use for formation of the bigger particles of colloidal dimensions. So let's see here, sulfur or phosphorus is not directly soluble in water. So if an unsaturated alcoholic solution of sulfur or phosphorus is found in water, a colloidal solution of sulfur or phosphorus is formed. So by changing the solvent, because sulfur and phosphorus they are not soluble in the water, that's why we are using alcoholic solutions for formation of the bigger particles of colloidal dimensions. So next we change the physical state. So mercury or sulfur solutions are prepared by allowing their vapors to pass through the cold water. So in this process, ammonium citrate is used to stabilize the solution. So by using or changing the physical state, which is useful for the formation of the bigger particles of colloidal dimensions. So next, controlled condensation. So here we using the Prussian blue solution is produced by the precipitating. It is then presence of protective colloidal system like starch. So here we using the controlled condensation by using the starch for the formation of the bigger particles of colloidal dimensions. So let's see some of the chemical methods which is used for the formation of bigger particles of colloidal dimensions. So here we use some of the chemical methods. So what are they? See here, decomposition of colloidal solution of a arsenious sulfide is made by passing hydrogen sulfide gas through the suspension of arsenium trioxide in water. So let's see here, arsenium trioxide react with hydrogen sulfide, which gives arsenium sulfide, so and water molecule. So next by reduction. So colloidal solution of a metal, we are using gold, silver, platinum in water can be prepared by reducing their aqueous uh, solution of their salts by reducing reductants like hydrogen. So gold chloride, we are using formaldehyde, and water we get the colloids. So the liberated acid is neutralized by potassium carbonate, earlier we discussed. So next we see the by oxidation. So here some of the non-metal solutions are prepared by passing this method. For example, mm, sulfur solution is prepared by passing H2S through a solution of sulfur dioxide in water until the smell of sulfur dioxide is removed. So by hydrolysis process, so we are using ferrous chloride in the presence of water, that is hydrolysis, we get hydroxide soul. Yes. So the dispersion medium. It is a direct technique. In this method that consists of finally fulfilling substances to be dispersed in the medium, which is to constitute the dispersion phase. So lastly, we see the by mechanical dispersion. So here, the we are using the suspension then passed between the two steel discs. Two steel discs. When these two steel discs are rotated with high speed, so the wherever the two discs rotating in opposite direction at high speed, so with the narrow clearness, the narrow space between the two metal discs break down, then the particles to colloidal size paint blocks in ointments. So then we are prepared by this method. So these are the some methods for preparation of colloidal solutions. So next we discuss the breadings or electrode dispersion method. So we discuss the electrode dispersion method for colloidal formation of colloid particles. So in this method, an electric current is passed through the water containing of alkali. When an electric arc is produced between the tips of two electrodes of these metals, the heat of the spark converts the ends of the metal rod to form a vapor of the metal, so which then they condense to give metal colloids. So finally the solution is cooled by cooling mixture, so that is alkali act as a stabilizer. The colloidal solution of metals like gold and silver, platinum, copper, etc. are prepared. So let's see the diagram. We see here we using high voltage of current. So, so by using this, we prepare the lyophilic colloidal salt. So we are using high voltage. So this is alkali plus salt. So these are metal rods. So we using metals, inert metals as silver or gold or platinum. So among these we are using silver as a coating electrode metal. So these two electrodes are immersed in the chamber containing a solution are known as aqueous solution. So this is called as a dispersion medium. So here these two electrodes are immersed in the solution are known as dispersed medium. So this electrode will act as an anode. So this metal electrode will act as a cathode. So one act as an anode, the other one act as a cathode. So here these two metal electrodes are connected with the high voltage. So the electrodes are connected with high voltage. So these two are forms a spark. So here, so we are using AU metal electrode. So the gold vapors are formed in this bottom of the metal electrodes. So there will be formed vapors of the gold. So in this method, the dispersion method, whenever the electricity passes through the electrodes, the particles are dispersed. That means a bulky material of a molecules are dispersed into smaller particles of a molecules. So here, this formation of vapors, so we here using ice. So these ice will cool down the formation of particles. So the ice should be cool down the formation of these vapor particles. So in this method, we prepare the lyophilic gold sol. So let's see here peptidization process. So in this peptidization process, breakdown of precipitate into colloidal form by adding an electrolyte solution is known as peptidization. So breakdown of precipitate into colloidal form, breakdown of precipitate into colloidal form by adding electrolyte solution is known as peptidization. So the electrolyte used in this method is termed as peptidizing agent. So freshly precipitated substance can be brought to a colloidal state by shaking with an electrolyte having common ion. So this is a precipitate. We use peptidizing agent as iron. We get a colloidal solution of iron oxides, hydroxides. So this is surface chemistry. So thanking you. So today we discussed the colloids in the surface chemistry. Thanking you.